In this video, we're going to cover section 9.4 on the preparation of alkynes. So we saw that we can prepare alkenes from alkyl halides. Now we can use that same strategy to prepare alkynes, except now we have to start with an alkyl dihalide. So an alkyl halide in which there are two leaving groups present, two halogens. So here's an example of an alkyl dihalide. And so under the conditions in the presence of a strong base, we'll observe the E2 reaction taking place, and that will form the alkyne. Just as we saw that an alkyl halide in the presence of a strong base will produce the alkene. So let's look at that reaction in a bit more detail. So you can see in this example, the dihalide, we refer to this as a geminal dihalide. Geminal meaning twin and having basically two halogens on the same carbon, as opposed to vicinal, in which the two halogens are on neighboring carbons. So for a geminal dihalide, in the presence of a strong base, the E2 reaction will occur twice. Through the first E2 reaction, you'll generate a bromoalkene, and then with the interaction or reaction of this bromoalkene with additional base, you'll end up with your final alkyne. Similarly, if we started with a vicinal dihalide in the presence of strong base, we would form also the alkyne. As long as we have a beta hydrogen for each halogen, we will see the elimination reaction occurring. So when we carry out these reactions, we need to have at least twice as much base present as we do dihalide, because the base is required twice to convert the dihalide to the alkyne. So for the preparation of terminal alkynes, we need more than just two equivalents of base to carry out the two successive E2 reactions. We actually require three equivalents, and that's to ensure that we go to completion with this particular reaction. And you can see in this example, if we're using sodium amide, a strong base in liquid ammonia, sodium amide, the amide ion, the active species, it will react with the dihalide to give you this particular terminal alkyne. But the problem with this reaction is that there may be some base present that can further react with this terminal alkyne to form the alkynide ion. So to ensure that there is enough base to go around, to ensure that all of the dihalide fully reacts to this stage, excess sodium amide is usually used. And so at a minimum, 3 equivalents of sodium amide is generally used in this reaction. And so by adding that extra or excess sodium amide, we're ensuring that we get to this point, that we form the alkynide ion. Now I know what we want is the terminal alkyne, but we go a little bit further past the terminal alkyne to ensure that all of the dihalide and all bromoalkene present in solution goes to the alkynide ion. And so then generally what happens is once we form the alkynide ion in a second separate step, we will, what we say, quench the reaction, or we will add, in this case, water to the reaction, and that water will react with the alkynide to form the terminal alkyne. It's at this point, because what we form from that reaction of the alkynide and water, what we form is a weaker set of acids and bases. We form a weaker acid, that of the terminal alkyne, and a weaker base is formed, the hydroxide ion. And so this ensures that you get completion of this particular reaction, that you actually form the terminal alkyne that you set out to make in the first place. So to show this in a synthetic step, we would use the following around our reaction arrow. So we would carry out this in 2 steps. The first step, so we have our numerical bullet, we would use excess, so we use XS, or you can spell it out, sodium amide, NaNH2, and that will be in liquid ammonia, an inert solvent for this strong base, so liquid ammonia. And it's in the second step that we would do that aqueous quench. So we do a water quench. We would add water slowly to the reaction mixture, and water will not only react with any excess sodium amide to give you ammonia, which is the solvent, but it will also ensure that you convert all the alkanide ion in solution to the terminal alkyne. So if you have any questions about the preparation of alkynes, please send me an email and we can discuss it further. Thank you.